Somewhere in your mind sits a picture of our sun as something enormous, a furnace so vast it could swallow 1,000,000 Earths. Hold that image close, because it is about to feel small. Far across the cosmos, inside a glittering nursery of newborn suns, burns a single star so heavy it strains the limits of what physics says should exist. Its name is R136a1, and beside it, our sun is barely a spark. Tonight we travel to meet a giant that rewrites the rules of stellar life. If this gentle journey through the cosmos helps you drift, a like and a subscribe let me keep making it. And before we begin, softly tell me, where are you listening from, and what hour glows on your clock? Let it begin with something close, something you have seen 10,000 times without ever truly looking at it. The Sunday, that ordinary brightness that warms the side of a building in the late afternoon. The thing you turn your face away from without thinking. The light that has been falling on this world since long before there was anyone here to feel it. Tonight, before we travel anywhere strange, I want you to sit with the sun for a while. I want you to know it the way you might know an old friend, slowly, generously, with attention. Because everything we are about to discover depends on first understanding the one star you already carry a picture of in your mind. Settle in. Let your shoulders drop. Let the day you have just lived begin to loosen its grip. You do not have to hold any of it right now. The weight of it can rest on the floor beside you, and we will leave it there together while we look upward. Picture the sun rising, not as a symbol, not as a feeling, but as an object. A vast sphere of glowing gas, hanging in space, burning. It does not sit on anything. It is not held up by anything. It simply hangs there in the dark, 93 million miles away, and it has hung there, more or less unchanged, for a length of time so long that the human mind has no real handle for it. When you watch a sunrise, you are watching something that is almost unimaginably old going about its quiet, patient business, exactly as it did when the first single-celled life stirred in the early oceans. Exactly as it will when you are asleep tonight, and the far side of the world turns its face toward that same fire. Let us talk about how large it is, because this is where the comfort begins, and it is a real comfort. The sun is big. Genuinely, satisfyingly big. If you wanted to fill the sun with planets the size of the Earth, you would need more than 1,000,000 of them. Sit with that number for a moment. Not 100 Earths, not 1,000, more than 1,000,000 worlds like this one, poured into the volume of a single star, and still there would be room to spare. Every ocean you have ever seen, every mountain range, every desert and forest and city, all of it gathered up into one round world, and you would need to do that more than 1,000,000 times over just to match the sheer size of the thing that warms your skin in the morning. And it is heavy in a way that is even harder to hold in the mind. The sun contains more than 99% of all the matter in our entire solar system. Think about everything that orbits it. The giant planets, Jupiter with its storms wider than the Earth, Saturn wrapped in its rings of ice, the smaller worlds, the moons, the asteroids, the comets that swing in from the cold edges of the dark and loop back out again. Every speck of it, every grain and boulder and frozen world, all of it together, take all of that, and it amounts to less than 1/100th of the family. The sun is the family. Everything else is a rounding error, orbiting around it. When you stand on the Earth, you are standing on one of the small leftover crumbs that did not quite make it into the star. Now feel the fire of it. Deep in the core of the sun, in a region you could never see and could never survive, something extraordinary is happening. And it has been happening without pause for billions of years. The pressure there is so immense, the heat so absolute, that the very centers of atoms are being forced to merge. Hydrogen, the lightest and simplest substance in the universe, is being crushed together until it becomes helium. And every time that happens, a small flash of energy is released. By itself, a single one of these flashes would be nothing. But it is not happening once. It is happening countless trillions upon trillions of times every single second throughout a region larger than many planets. And the combined glow of all of it is the light that crosses the emptiness of space and arrives 8 minutes later as the sunshine on your window. That is worth pausing on. The light that warmed you today did not come from nearby. It began its journey at the heart of the sun, fought its way outward over an unthinkably long span, finally escaped from the surface, and then crossed 93 million miles of empty space to reach your face. The warmth you felt was, in a real and literal sense, a message sent from the core of a star, 8 minutes old by the time it touched you. You have been receiving these messages your whole life. So did everyone before you. So will everyone after. And here is the part that makes the sun feel less like a furnace and more like a steady companion. It is not in any hurry. The sun has been burning like this for about 4.5 billion years, and it will go on burning, gently and reliably, for billions more. It is not even halfway through its life. When you lie down to sleep tonight, the sun is roughly in the middle of a story so long that the entire span of human existence, every empire, every language, every person who has ever lived and died, fits into a sliver of it too thin to notice. The sun does not flicker, it does not lurch. It rises and it sets and it rises again, and it has done so with such faithfulness that life itself learned to build its rhythms around the certainty of it. Your own body still keeps time by it. The slow tide of waking and sleeping that you feel even now is, in the end, a habit your ancestors inherited from a star. So you can be forgiven for feeling that you understand the Sunday. You do, in many of the ways that matter. You know it is enormous. You know it is ancient. You know it is heavy beyond reckoning and patient beyond imagining. You know that it could swallow 1,000,000 Earths, and that everything else in our corner of space is just a scattering of small things turning around its light. This is real knowledge, and it is good knowledge, and you should feel a quiet satisfaction in holding it. For most of the long story of our species, this was very nearly the whole picture. The sun was the great fire in the sky, the source of warmth and time and life, the largest and most important thing anyone could conceive of. To the people who came before us, the sun was not a star among stars. It was the center, it was the measure of all things. And for a very long time, when human beings finally began to suspect that the small points of light scattered across the night were other suns, they assumed that our sun was a perfectly representative one, maybe even a large and impressive example of the breed. Why would we not think so? It was the only star we could see up close. It was the only one whose size and weight and fire we could begin to measure. When you have only one example of something, and that example is the brightest thing in your entire world, it is the most natural thing imaginable to assume it sits somewhere near the top. This is where I want to set down the first small stone, very gently, and let you feel its weight. Because that assumption, the comfortable and reasonable assumption that the sun is a grand and typical star, turns out to be only half true, and the half that is false is going to open a door that, once opened, cannot be closed again. Here is the true part first, so that nothing feels taken from you. The sun is, in many respects, an ordinary star. It is not a freak. It is not a rarity. Across the vast population of stars that fill our galaxy, there are countless others that are broadly similar to it in size and behavior, middleweight stars burning steadily through long lives. In that sense, the sun is unremarkable. It is one face in an enormous crowd, and it would not turn a single head among the stars. But now hold that thought against this one. When astronomers finally began to take the true measure of the stars, when they learned to weigh them across the impossible distances, to read their colors and decode their light, they discovered something that the ancient assumption had never prepared anyone for. The sun is not large among stars. In the full range of what a star can be, the sun is small. Not small in the way a candle is small next to a bonfire, small in a way that is far stranger and far more humbling than that. There exist stars out there, real stars, burning right now in the dark, that make the sun look like the faintest possible ember, stars beside which 1,000,000 Earths is not a boast but a quiet joke. Stars so far beyond our own in heft and fury that the words we have been using, big, heavy, ancient, simply break apart and have to be put back together in some larger shape. This is the tension I want you to carry with you for the rest of our journey tonight, because everything turns on it. There is a difference, a deep and slippery difference, between what feels enormous and what truly is enormous. The sun feels enormous to us, and rightly so, because we are tiny and it is the largest thing in our daily lives. But feeling is not the same as fact. The scale of our own experience is a kind of lantern. It lights up the little patch of the world we stand in, and beyond the edge of that light, things go on at sizes our feelings were never built to register. The sun sits at the very edge of that lantern light. It is the largest thing our intuition can almost hold. And just past it, in the dark, our intuition cannot reach. There are things that would not even notice the sun if it drifted past them. Notice how that lands in the body. There is something almost vertiginous in it, a small lurch, like missing a step in the dark. For your whole life, the sun has been the great example of bigness. To be told, calmly and truthfully, that it is closer to small than to large, is to feel the floor of your sense of scale shift very slightly underfoot. Stay with that feeling. Do not push it away. That gentle disorientation is not a problem to be solved. It is the beginning of seeing more clearly. Every astronomer who has ever truly understood the size of things has felt it too. You are in good company. The surprise you feel is not ignorance. It is the start of knowledge. So let us not rush. Let the sun remain for one more quiet moment, exactly as you have always known it. Warm, faithful, vast beyond 1,000,000 worlds, ancient and patient and dependable. Let it be the largest thing you know, one last time, the way it has been the largest thing every human knew for nearly all of our history. There is no shame in having stood inside that picture. It is a beautiful picture, and most of it is true. And then, slowly, I want you to turn your attention away from the bright daytime sky and toward the night. Imagine yourself outside, late, in the dark, where the air has gone cool and the stars have come out one by one. If you were standing far to the south, beneath skies that most people in the northern half of the world never see, you would be able to find, low against the dark, a faint and unassuming smudge of light. Not a star, exactly. Softer than that. A small, pale, hazy patch. The kind of thing you might mistake for a wisp of cloud or a smear on a lens. Most people who have looked up at it across the centuries gave it no more than a passing glance. It does not announce itself. It does not blaze. It simply hangs there, dim and quiet, near the bottom of the southern sky. That faint smudge is not a cloud. It is not nearby. It is a whole separate island of stars, drifting alongside our own galaxy in the great dark, so far away that its light has been traveling toward you for longer than there have been cities on the earth. And buried deep inside that distant haze, in a fevered region where stars are being born by the thousands, there lives something that the sun, for all its glory, cannot begin to rival. something so heavy, so violent, so far past the gentle fire we have spent this whole time admiring, that when you finally stand before it, the sun you thought you understood will shrink in your mind until it is no larger than a single candle flame, guttering quietly in an enormous and indifferent dark. We are going to travel to that smudge of light. We are going to go inside it. We are going to find the heaviest known star in all the heavens, and we are going to stand as close to it as understanding will allow. And we are going to learn what it means for something to be so massive that it sits at the very edge of what the universe will permit a star to be. But not yet. For now, simply hold the two pictures side by side in the quiet of your mind. The sun, warm and familiar and vast, the great fire of all our days, and that faint southern smudge, soft and silent and almost ignorable, hiding inside itself a giant that will make the sun feel small. Hold them both. Feel the strange, gentle ache of knowing that the larger one is the one you can barely see. Breathe in slowly. Breathe out. The sun will rise again tomorrow, faithful as ever, and you will feel its warmth on your skin, and now you will carry a small secret with you when you do. You will know that the great fire of your sky is, in the wider dark, only a modest and patient little star, and somewhere far to the south, behind the daylight, a far greater fire is burning and waiting, and we are going to go and meet it. Stay with me. The journey outward is just beginning, and the next step takes us into the strange and beautiful question of what it even means for one star to be greater than another. Because the answer, as you are about to find, is not at all what you would expect. Before we go any further, before we cross all that dark to reach the giant waiting inside the southern haze, we have to slow down and untangle something. Because there is a knot hidden inside the way we talk about stars, and if we do not loosen it now, gently, with our fingers and not in a hurry, then everything that comes after will feel confused. It is a simple knot, most knots are, but the universe has tied it so cleverly, and we walk past it so often without noticing, that almost everyone gets caught in it at least once. Tonight, we are going to take it apart together, one loop at a time, and when we are done, you will see the stars a little differently for the rest of your life. Here is the knot. We have two words, and we use them as if they mean the same thing, and they do not. The words are big and heavy, largeness and weight, size and mass. In our daily lives, these two ideas travel together so often that we have stopped noticing they are separate. A boulder is big and it is heavy. A mountain is large and it is impossibly weighty. A truck is bigger than a bicycle and it is heavier too. Over and over, our ordinary experience teaches us that the bigger thing is the heavier thing, until the lesson sinks so deep that we forget it was ever a lesson at all. It simply becomes the way we expect the world to work. Bigger means heavier. We learn it as children lifting things, and we never think to question it. But the universe does not feel bound by the habits of our hands. Out among the stars, size and weight come apart from each other, and they come apart so dramatically that the gap between them becomes one of the most important things you can possibly understand about what is up there. Bigness is one thing, heaviness is another, and the universe, it sometimes seems, takes a quiet delight in confusing the two, in building things that are enormous and yet feather light, and other things that are modest in size and yet so heavy they bend the fabric of space around them. Tonight, the difference between these two ideas is the single most useful thing you can carry. So let us make it solid. Let us make it something you can almost hold. Think about your own hands for a moment. Imagine I place into your left hand a beach ball, a big one, the kind a child can barely wrap their arms around, brightly colored, taut with air. It is large. It fills your vision. It is, by the simple measure of how much space it takes up, an impressive object. Now imagine I place into your right hand a small ball of iron, a cannonball, dark and dense, no wider than an orange. It is small. It would disappear behind the beach ball completely. By the measure of size, there is no contest at all. The beach ball wins, easily, overwhelmingly. And yet, you know without my telling you which hand is going to ache. You know which object you could carry across a room and which you would have to set down after a few steps. The little iron ball, the small dark thing that the beach ball could hide behind without effort, is the heavy one. It is the one with the real substance packed into it. The beach ball is almost entirely air, a thin skin stretched around a great volume of nothing much. The cannonball is matter all the way through, tight and solid and unyielding, size in one hand, weight in the other. And the smaller object holds far, far more of the thing that actually counts when you ask how much is really there. This is the whole secret, and you already understand it, because you have lifted things your entire life. You have felt the difference between a large empty box and a small full one. You have picked up a pillow and a stone of the same size and felt your arm respond completely differently to each. The knowledge is already in your body. All we are doing tonight is taking that bodily knowledge, that quiet wisdom in your muscles, and carrying it up into the sky, where it turns out to matter more than almost anything else. So now, let us go up. Let us hold this distinction carefully, like a candle we do not want to blow out, and let us walk it out into the dark to meet the largest star most people have ever heard of. Far across our own galaxy, much closer to home than the southern smudge we are ultimately traveling toward, there burns a star with a strange and lovely name, Scuti. Say it slowly. It sounds like something out of an old story, and in a way it is, because it is one of the great characters in the story of how big a thing can be. Scuti is what astronomers call a red supergiant, an aging star swollen to a size that defies the ordinary imagination. And when it comes to sheer bigness, to the raw question of how much space a single star can occupy, Scuti is one of the undisputed titans of everything we have ever found. How big? Let us do this carefully, because the number deserves it. You remember our sun, the great fire we spent all our quiet time with, the star that could swallow more than 1,000,000 Earths. Hold that image. The sun as the largest thing your intuition can almost grasp. Now understand this. If you could somehow set Scuti down where our sun is, with its center exactly where the sun's center sits, its glowing surface would not stop at the Earth. It would not stop at Mars. It would swell outward, swallowing Mercury, swallowing Venus, swallowing the Earth, swallowing Mars, reaching out and out across the solar system until its boundary lay somewhere out past the orbit of Jupiter. Everything you think of as the inner solar system, all those worlds, all that space between them, would simply be inside this single star, lost somewhere in its glowing interior like specks of dust in a lit room. Let that settle. If you stood on the Earth's orbit and this star were in the sun's place, you would not be looking up at it. You would be inside it. The sky in every direction would be the star. The numbers, when you reach for them, almost stop meaning anything. To match the volume of Scuti, to fill it up, you would not need 1,000,000 suns the way you need 1,000,000 Earths to fill our own star. You would need something closer to several billion suns. Billions. Take our sun, the fire that humbles every human intuition, and pour it into Scuti, and you would have to do it billions of times over before the great red giant was full. By the measure of size, by the simple question of how much room a star takes up, this is one of the most colossal objects we have ever laid eyes on. It makes our sun look like a marble. It makes the sun look, frankly, like the candle I promised you the sun would one day resemble. So there it is. The contest seems over before it began. We set out tonight in search of the greatest star, and surely this is it. Surely the heaviest, the mightiest, the most extreme star in all the heavens must be this swollen crimson colossus that swallows whole solar systems. What could possibly be more than this? The question seems to answer itself. Size has spoken, and size has spoken in a voice billions of suns deep. And here is where I have to ask you to remember the beach ball. Because UY Scooty, for all its breathtaking width, for all those billions of suns it could hold, is hiding something. It is hiding the same secret the beach ball was hiding. It is enormous, yes, but it is not heavy in proportion to its enormousness, not even close. UY Scooty is a dying star in the late bloated chapters of its life, and in that chapter a star puffs itself outward to monstrous size, while its outer layers grow thinner and thinner, more and more diffuse, until the great glowing body of the thing is mostly a vast and tenuous cloud. If you could journey into its outer regions, you would find them shockingly empty. The gas there is spread so thin, so gossamer, that by the standards of the air you are breathing right now, it would count as a very fine vacuum. The star is gigantic the way a thundercloud is gigantic. It fills the sky, and it weighs almost nothing for its size. How much does it actually weigh, this swallower of solar systems? Here is the quiet shock of it. Despite being large enough to hold billions of suns, UY Scooty contains only somewhere around 10 times the matter of our single Sunday. Perhaps a little more, perhaps a little less. The measurements are difficult across such a distance, but the shape of the answer is what matters. A star that could hold billions of suns by volume holds only a handful of suns by weight. All that staggering size and the actual substance packed into it, the true amount of stuff, is modest. It is the beach ball, exactly. A great taut skin of glowing thinness stretched around an enormous volume of almost nothing. The bigness is real. The bigness is awe-inspiring. But the bigness is mostly empty. Feel the floor shift again. The way it shifted when you learned the sun was small. We thought the contest was settled, and it was not even the right contest. We were weighing the beach ball by its width and declaring it the heaviest thing in the room. The universe let us believe it for a moment, the way it loves to, and then quietly turned our own assumption against us. So if size is not the true measure of a star's greatness, then what is? This is the heart of everything. So let us say it plainly and let it land. The thing that truly counts, the thing that decides a star's whole destiny, its life, its fury, and the strange manner of its death, is not how much space it fills. It is how much matter it contains, its mass, the actual quantity of substance gathered into it, the cannonball, not the beach ball, the weight in the hand, not the width across the eye. And this matters far more than it might first seem, because mass is not just a number on a scale. For a star, mass is fate. The amount of matter a star is born with determines almost everything about the life it will lead. It decides how fiercely the star must burn to hold itself up against the crushing inward pull of its own weight. It decides how hot the core will run, how bright the surface will blaze, how quickly the fuel will be devoured, and how long the whole burning life will last. It decides, in the end, how the star will die and what it will leave behind. A star's mass is its character and its prophecy, written into it at birth. Two stars of wildly different size can lead similar lives if their masses are similar. But two stars of similar size can lead utterly different lives and meet utterly different ends if one is heavy and one is light. Size is the costume, mass is the soul. This is why the truly extreme stars, the ones that sit at the genuine frontiers of what is possible, are measured not by how wide they are, but by how much they weigh. And this is the crown we are actually traveling toward tonight. Not the widest star, not the most swollen cloud of thin glowing gas. We are going in search of the heaviest known star in all the heavens. The greatest concentration of matter that has ever been confirmed, gathered into a single burning body, the cannonball among stars, the true and rare and frightening crown of weight. And here is what makes that crown so much stranger and so much harder to wear than the crown of size. The universe finds it easy, in a sense, to make something big. Puff up a dying star and it will swell to enormous width on its own. But to gather an immense amount of matter into a single star and have it hold together, burning without tearing itself apart, is something the universe manages only rarely and only barely, and only for a very short time. Heaviness, real heaviness, pushes against the limits of what a star is even allowed to be. There is a ceiling somewhere, a point past which a star simply cannot hold so much matter and survive. And the giant we are going to meet lies pressed right up against that ceiling, straining at the very edge of the possible. So the contest we thought was over is not over. It was never really about size at all. UY Scooty keeps its own crown, the crown of bigness, and it is a magnificent crown, and we honor it. Let it reign over all the wide and swollen things, the beach balls of the cosmos, the vast thin clouds of glowing gas that could swallow worlds. We take nothing from it. But there is another crown, harder to win and far more dangerous to wear, and it does not go to the widest, it goes to the heaviest. And that crown belongs to a star you have not yet met, a star far smaller in size than UY Scooty, a star you could fit inside the red giant countless times over, and yet a star that carries within its modest body so much more matter, so much more true substance, that it lives a life of violence and brilliance the bloated old giant could never know. Hold the beach ball and the cannonball in your two hands one last time as you drift here in the quiet. The beach ball is vast and gentle and nearly empty. The cannonball is small and dark and unbearably dense. We have spent long enough admiring the beach ball of the sky. Now we turn, at last, toward the cannonball, toward weight, toward the heaviest fire ever found. And to reach it, we have to leave our galaxy entirely. We have to cross a gulf so wide that the very distance will become part of the wonder. So let your breath go slow, and let the beach ball drift out of your hands, and keep only the small, heavy truth we worked so hard to uncover tonight. Bigness is not heaviness. Size is not mass. And the greatest star is not the one that fills the most sky. It is the one that holds the most within. The journey across the dark begins next. Rest here a moment first. We have a long way to go. Now we travel. And I want you to feel the distance, not just hear it, because the distance is part of the wonder. It is not an obstacle between us and the giant. It is the first thing the giant has to teach us. So let us go slowly, the way you would on a long journey at night, watching the familiar fall away behind you a little at a time. Begin here, in your room, in the dark, with the small heavy truth we uncovered together still resting in your mind. Now lift gently away from it. Rise above the roof, above the town, above the soft scattered lights of the place you live, until the ground below becomes a quilt of glow and shadow, and then nothing you can pick out at all. Higher still, until the curve of the earth shows itself, that gentle blue arc you have seen in photographs, the thin, bright skin of atmosphere holding all the weather and all the breathing things, the entire stage of every life that has ever been lived, shrinking now beneath you into a single turning sphere. There it is, everything you have ever known, all of it, on that one blue world growing smaller below. Keep rising. Let the earth become a marble, then a bright point, then lose itself among the other points entirely. Now you are out among the planets, and you can see the sun behind you, our sun, the great fire we honored. And from out here you can already feel the lesson of the last part settling into your bones. Because the sun, from this distance, is just a particularly bright star, one among many, the largest thing in our daily lives, reduced to a single shining dot in a vast scattering of dots. Keep going. Let even the sun shrink until it joins the crowd, until you could no longer point to it and say with certainty, there, that one is home. Now you are inside the Milky Way, our galaxy, and for the first time you can begin to take its true measure. All your life, the stars in the night sky have seemed like a scattering of separate lights pinned to a dark dome. But from out here you can see that they belong to something. They are part of a vast, slowly turning wheel of stars, a great flattened disk wound into glowing spiral arms, hundreds of billions of suns drifting together through the dark, in a structure so wide that light itself, the fastest thing there is, takes 100,000 years just to cross from one edge to the other. Our sun lives out toward the quiet edge of one of those arms, an ordinary citizen of an enormous city, circling the distant center along with all the rest, taking something like 200 million years to complete a single lap. You have never felt this lap. No one ever has. We are all carried along on it, every moment of every life, riding a turning galaxy without the slightest sensation of motion. Sit in that for a moment. Hundreds of billions of stars. Our sun, the fire of all our days, just one of them, out near the rim. And this entire glowing wheel, this is only home. This is the small, familiar place. Because tonight we are not staying inside the Milky Way. Tonight, for the first time on our journey, we are going to leave our galaxy altogether and cross the dark between galaxies to reach another one. So turn your gaze outward, past the edge of the spiral, into the deeper black beyond, and there, hanging in that outer dark, you would see it. A separate cloud of stars, smaller than our own great wheel, softer, less grand, drifting alongside the Milky Way like a small boat keeping pace with a great ship. This is the Large Magellanic Cloud. It is a galaxy in its own right, a companion to our own, bound to us by gravity, circling us slowly across spans of time that make a human life vanish into nothing. It holds billions of stars of its own, and it is the faint southern smudge I asked you to find in the night sky all those parts ago. That dim, pale patch low against the dark, the one most of the world never sees, the one you might mistake for a wisp of cloud. That smudge was never a cloud. It was an entire galaxy, seen from across an ocean of emptiness so wide the mind goes quiet trying to hold it. How wide? Here is where I want you to stop reaching for the number and start trying to feel it. The Large Magellanic Cloud lies roughly 160,000 light-years away from us. Now, a light-year is already a distance that breaks the imagination. It is how far light travels in a single year, and light is so fast that it could circle the entire Earth more than 7 times in 1 second. In 1 second. So let that beam of light fly, not for a second, not for a year, but for 160,000 years without stopping, and the distance it covers in all that time is the gulf we are now crossing. That is how far away the giant lives. Let me make that span touch the body, because a number that large is just a word until you do. The light that is arriving at our telescopes tonight from the Large Magellanic Cloud, the light we use to study it, did not set out recently. It left that galaxy around 160,000 years ago. Think about what that means. When that light began its journey across the dark, there were no cities anywhere on Earth. There was no writing, no agriculture, no wheel. The great cave paintings had not yet been made. The pyramids lay more than 150,000 years in the future. Human beings existed, yes, small bands of them, living by firelight and following the herds. But everything we would ever call history, every empire and every language and every face you have ever known, all of it was still unimaginably far ahead. That light has been traveling toward us, silently, through the emptiness, for the entire span of the human story, and then some, and it is only now arriving. When you look at the large Magellanic Cloud, you are not seeing it as it is. You are seeing it as it was before your species had a single word for the sky. Hold that, gently. The faint smudge in the southern night is a message older than memory, older than story, older than nearly everything we think of as human. And we are about to fly straight into the heart of it. So cross the dark with me now. Cross all that emptiness, 160,000 years of it, in the space of a few breaths, because in imagination we are not bound to the speed of light. Watch the large Magellanic Cloud grow from a faint smudge into a soft, glowing haze, and then into something with structure, with bright regions and dark lanes. A whole, untidy, beautiful galaxy resolving itself before you as you approach. It does not have the neat grand spiral of the Milky Way. It is looser, more ragged, a scattered and irregular cloud of billions of stars, with great clots of brightness here and there where something fierce is happening. And one of those bright regions, as you draw closer, begins to outshine all the others. One region near the edge of the galaxy is blazing with a light so intense that even from across all that distance it stands out like a beacon. We are going there. That is the place. As you fall toward it, the single bright patch begins to open up, the way a distant city opens up into streets and buildings as your train pulls in. And what unfolds before you is one of the most extraordinary places anywhere in the known universe. It has a name that sounds almost playful for something so immense: the Tarantula Nebula. It earned that name from the way it looks through a telescope. From a great distance, it shows long, curving streamers of glowing gas reaching outward from a bright central knot, spreading and branching like the legs of an enormous spider crouched in the dark. But the name, charming as it is, does not begin to prepare you for the truth of the place. Because the Tarantula Nebula is not a small thing with delicate legs. It is a vast and roiling region of glowing gas and dust. A cloud so enormous that if you could somehow move it close to us, if you could set it where the nearest familiar nebulae sit in our own galaxy, it would stretch across a huge swath of our night sky and cast shadows on the ground by its own light. It is one of the largest and most active regions of starbirth known anywhere in our entire corner of the universe, and we are flying directly into it. Slow down now. Let yourself drift inward, into the glow, and look around. This is unlike anywhere we have been tonight. The emptiness of intergalactic space is behind you. Here, everything is alive with light and motion and slow violence. Around you rise great walls and sheets of glowing gas, lit from within by the ferocious light of newborn stars, painted in the colors that hot gas gives off when it is set ablaze. The deep reds and pinks of glowing hydrogen, the harder blues and greens where other elements burn. There are towering ridges and pillars of darker dust, dense and cold, sculpted into strange flowing shapes by the relentless winds and radiation pouring off the young stars nearby. There are cavities, great hollow bubbles blown into the cloud where the most powerful stars have cleared the gas away around themselves with the sheer pressure of their light. It is a landscape, though landscape is too still a word for it. It is a weather. It is a storm of creation, frozen to our eyes only because it moves on a scale of time so vast that a human life is too brief to see it stir. And it is fevered. That is the word I keep returning to. Fevered. Because this is a nursery, and it is one of the most fertile and frantic nurseries the universe has to offer. Stars are being born here. Not one at a time, the way our own sun was born in some quieter cloud long ago, but in tremendous numbers, in great clustered broods, hundreds and thousands of new suns igniting out of the collapsing gas. Everywhere you look, matter is gathering itself, drawing together under its own weight, growing hotter and denser at the center, until at last the fire catches and a new star flares into being. The whole nebula glows because of these newborns, because their fierce young light pours out into the surrounding gas and sets it shining. The tarantula is bright the way a city is bright at night, lit by the countless windows of the things being born inside it. Take a moment to feel the strangeness of having traveled here. You began in your dark, quiet room with the small, ordinary fact of your own breathing. And now you are drifting inside a galaxy that is not your own, deep within a glowing storm of newborn stars, 160,000 years of empty dark behind you, surrounded on every side by the raw machinery of creation lighting up the night. The same physics that lit our own sun is at work all around you here, repeated thousands of times over, in a place far grander and far more violent than the gentle cloud that made us. And somehow none of it touches you. You float through it, watching, the way you might walk through a vast cathedral while a storm rages outside the windows, held safe by the simple fact that you are only here in the mind. But we have not come merely to admire the nebula, breathtaking as it is. We have come for something specific. We have come for the heaviest known star in all the heavens, and it is not scattered loosely among these glowing clouds. It is gathered with thousands of its siblings into a single place. So now, narrow your gaze. Pull your attention away from the wide sweep of the streamers and the sheets and the towering dust, and look toward the center. Look toward the brightest part of all. Because at the heart of the Tarantula Nebula, in the very core of all this fevered creation, there is a place where the light becomes almost too intense to look at. The streamers you saw from far away, the great curving legs of the spider, they all reach back toward this single blazing center, as if the whole enormous structure were arranged around it, drawn outward by it, lit by it. And that is very nearly the truth. Almost all the light that makes the tarantula glow, almost all the energy that lights up this entire vast region across thousands of light years, pours out of one small dense knot of stars sitting right at the middle. Let yourself fall toward it. Watch the surrounding nebula widen and slip past you as you descend toward the center, the great clouds becoming a glowing backdrop, the brilliant core growing and growing in front of you until it fills your vision with light. It is not a single star. From this distance you can begin to see that. It is a crowd. A staggeringly dense crowd of stars, packed together far more tightly than anything in the calm neighborhood around our own sun, a glittering swarm of the brightest, hottest, most massive stars the universe knows how to make, all gathered into one small region of space, all blazing at once. This is the cluster. This is the city of giants we have crossed a galaxy to reach. It has a designation, plain and unromantic, the way astronomers often name the most extraordinary things. R136. Say it quietly to yourself, because you will be hearing it for the rest of our journey. R136. A knot of stars so luminous, so crowded with monsters, that it powers an entire nebula visible from across the dark between galaxies. And somewhere inside that blazing swarm, Hidden among siblings that are themselves giants beyond anything our sun could dream of being, sits the one we came for, the heaviest, the cannonball among cannonballs, the star pressed right up against the very edge of what a star is allowed to be. But we are not quite there yet. First we have to enter the cluster itself, this impossible city of light, and learn what it is like to stand in a place where the gentle emptiness of our own sky is replaced by a crowd of blazing giants pressed shoulder to shoulder in the dark. So rest here a moment, drifting before the brilliant core, with the whole fevered nebula glowing at your back and a galaxy of distance behind you. Breathe slowly. We have come very far tonight, and the most extraordinary part of the journey is the part that still lies just ahead, glittering, waiting at the center of the light. So let us enter the city. Let us drift in from the glowing edges, past the last reaching streamers of the nebula, toward that blazing knot at the center, and let us see what it is to stand inside R136. Move slowly. There is no hurry here, and there is something in this place that asks to be approached the way you would approach something sacred, with quietness, with attention, with a willingness to be made small. To understand what you are about to see, you have to first remember what you are used to. Remember the neighborhood around our own Sunday. It is, above all else, empty. Our sun drifts through the galaxy in spacious solitude, and its nearest stellar neighbor lies more than 4 light years away. 4 light years. We have already learned how vast a single light year is. That gulf light takes a whole year to cross. Now stretch that more than 4 times over, and that is the distance to the very closest star to our own. The space between our sun and its nearest neighbor is so enormous, so profoundly empty, that if you shrank the sun down to the size of a grain of sand, the next grain would lie miles away across an otherwise empty field. That is the ordinary condition of stars: vast loneliness, great oceans of dark between small scattered fires. This is the calm, quiet emptiness in which our sun was born and has always lived. It is the only kind of stellar neighborhood any of us has ever known. Now, let that picture dissolve and look at where you are. Here, in the heart of R136, the emptiness is gone. The great spacious dark that surrounds our sun has been replaced by a crowd. The stars here are not scattered grains of sand miles apart across an empty field. They are packed together, gathered into a tiny volume of space, pressed so close that the whole region blazes as a single overwhelming glow. Thousands of stars are crammed into a span of space that, out in our own quiet corner of the galaxy, might hold only a handful. If you could stand on an imaginary world somewhere inside this cluster and look up, you would not see the gentle scattered stars of a familiar night sky. You would see a sky on fire. Brilliant suns crowding the dark in every direction, dozens of them blazing brighter than the full moon, the whole heavens lit so fiercely that there would be no true night at all, only a perpetual blue-white blaze pouring down from a sky packed with giants. And these are not gentle stars. This is the part that makes R136 so unlike anything in our experience. The cluster is young, astronomically speaking, only a few million years old, which for stars is the equivalent of the very first moments of infancy, and in that youth it has produced an extraordinary brood. R136 is crowded with the hottest, brightest, most massive stars the universe knows how to assemble. Not 1 or 2 of them as rare exceptions, but a whole dense population of them packed together, blazing all at once. These are stars so luminous that a single one of them can outshine our sun by 1,000,000 times or more. And the cluster holds many of them, gathered into the same small space, pouring out so much combined light and energy that, as we saw, they light up an entire nebula thousands of light years across. When you look at the glowing tarantula from afar, you are very nearly looking at the work of this one cluster. R136 is the furnace. Everything else is the glow it casts. Let yourself feel the strangeness of standing among them. Each of these stars, taken alone, set down by itself in our own quiet sky, would be a monster, a wonder, the most extreme object for light years in every direction. Any single one of them would dominate our heavens, would rewrite our sense of what a star could be. And here they are not exceptional. Here they are the ordinary residents. Here, a star 1,000,000 times brighter than the sun is simply a neighbor, one face in an enormous crowd of faces, jostling for room in the most crowded and luminous stellar city we have ever found. The scale of it keeps doing this to us, the way the whole journey has. Every time we think we have arrived at the extreme turns out to be merely the local background, the everyday, against which something even greater stands out. Because somewhere in this blazing crowd, among all these giants, there is one that the others cannot match, one that stands out even here, even among siblings that would each be a marvel anywhere else. The heaviest of them all, the one we came for. And here we arrive at something that I find genuinely moving, a part of this story that is not about the star itself, but about us, about the long, patient effort of human beings to see clearly across an impossible distance. Because for a long time, we could not. Think about what we are actually trying to do. We are standing on the Earth, or just above it, 160,000 light years away from this cluster, and we are trying to pick out, from within a dense, blazing swarm of thousands of stars packed tightly together, one individual star among them, and to measure it. Imagine standing on one shore of an ocean and trying to distinguish the flame of a single candle from the flame of the candle right beside it, when both candles are burning on the far shore, thousands of miles away, lost in the glow of thousands of other candles all crowded together. From that distance, the candles blur into one. Their separate lights smear together into a single patch of brightness, and no matter how hard you stare, you cannot tell where one ends and the next begins. This is the problem the cluster posed to us. From 160,000 light years away, the stars at the heart of R136 are so close together in our view that their light runs together into a single confused glow. And so for years, this is exactly what we saw. When astronomers first turned their instruments toward the core of R136 decades ago, they could not see individual stars there at all. They saw a bright blur, a single, intense knot of light. And the light pouring out of that knot was so tremendous, so far beyond what any ordinary star could produce, that some astronomers wondered whether it might be coming from something truly impossible. A few even proposed that the central object might be a single colossal star of utterly absurd mass, hundreds upon hundreds of times the weight of the sun, larger than anyone believed a star could be. Others suspected the truth was subtler, that the blinding light was not one object at all, but many, a tight knot of separate stars whose individual lights we simply could not pull apart from such a distance. This was a genuine question. I want you to sit with how real and how difficult it was. It was not obvious. It was not something anyone could simply look up and settle. Whether the brilliant heart of R136 was one monstrous star or a cluster of several crowded together was for a long while a true mystery, the kind that good and careful people disagreed about, the kind that could only be settled by seeing more clearly than anyone had managed to see before. And seeing more clearly across 160,000 light years is among the hardest things our species has ever tried to do. So we built better eyes. This is the quiet heroism running underneath the whole story. The slow improvement of our instruments, generation after generation, each one peering a little deeper into that stubborn blur. And here is where the layered zoom of our whole journey reaches its most beautiful moment, because it happened not just in imagination, but in reality, in history, as our telescopes grew sharper. At first, the blur, a single patch of overwhelming light, refusing to give up its secrets. Then, with sharper instruments, the blur began to break apart. What had seemed like one object resolved into several. The single knot of light, examined more closely, revealed itself to be a small handful of separate bright sources crowded together. Already this was a triumph, the first splitting of the smear into pieces. But it was not enough. Even those separate sources were suspected of being made of still smaller pieces, individual stars sitting so close together that even the improved instruments could not fully separate them. Then, sharper still, telescopes lifted above the blur of our own atmosphere, looking down through the clean dark of space, began to pull the cluster further apart. The handful of bright sources resolved into more sources, finer, more distinct. The crowd was beginning to show its individual faces, and one of those faces, one particular point of light, was beginning to stand out as the brightest of them all, the one pouring out more light than any of its neighbors. And then, in time, with the very sharpest instruments we have yet devised, instruments designed specifically to defeat the blurring and tease apart objects sitting almost impossibly close together in our view, the final separation came. Astronomers were at last able to look at that brightest point of light and confirm what it truly was. Not a tight little cluster of several stars masquerading as one. A genuine, single, individual star, one body, one fire. The brightest and the heaviest of all the giants, crowded into the heart of R136. We had finally pulled it free from the crowd, isolated it, seen it for what it was, across a gulf of 160,000 light years. Take a moment to honor what that means. There were people who spent careers on this question, people who built the instruments, who refined the techniques, who stared at the blur and refused to accept that it could not be resolved. People who proposed the impossible single star, and people who argued for the crowded cluster, and who pushed each other across years toward a clearer answer. The simple fact that we can now say with confidence that brightest point of light is one star, and here is roughly how heavy it is, represents the patient work of many minds across a long stretch of time, all of them reaching across an unimaginable distance to bring one faint point of light into focus. The star did not change. It has been burning there, unbothered, indifferent to us, for the few million years of its short, fierce life. What changed was us. We learned to see it. And now that we can see it, now that it has been pulled free from the blur and given its own separate existence in our understanding, it sits before us, waiting at the center of the most crowded stellar city in the known universe, the brightest member of a brood of giants, the one that stands out even here, even among siblings, any one of which would humble our Sunday. We have crossed a galaxy to reach it. We have entered the city of giants and stood in its blazing, sleepless light. And we have watched human ingenuity slowly, patiently pull this single star out of a smear of light that hid it for years. It has a name now, a name that has been waiting at the edge of this whole journey. The brightest star in the heart of R136, the heaviest known star in all the heavens, R136a1. Hold the name gently. We have earned our way to it, step by step, from the warm, familiar sun through the difference between size and weight, across the dark between galaxies, into the fevered nebula, and now into the crowded city at its heart, where human patience finally separated one fire from the crowd. Everything until now has been the approach, the long, reverent walk toward the thing itself. And now we are standing before it, close enough, at last, to truly meet it. Close enough to ask the questions we have been carrying all this way. How heavy is it really? How fiercely does it burn? What is it like, this single star that outshines a city of giants and sits pressed against the very edge of what a star is permitted to be? Rest here a moment in the blazing light of the cluster, with R136a1 finally resolved and waiting before you. The crowd of giants blazes all around, the nebula glows beyond, and one fire, the greatest of them all, burns quietly at the center of it, ready at last to be known. We meet it properly next. Breathe slowly. You have come so very far to stand here. So here it is, after the warm, familiar sun, after the long lesson of weight against size, after the dark between galaxies and the fevered nebula and the blazing, crowded city, here at last is the star itself. R136a1. Let us not rush the meeting. We have come too far to glance at it and move on. Let us stand before it the way you would stand before something you traveled your whole life to see, and let it slowly become real to you. The first thing to understand is that this is not a gentle star. Our sun, for all its fire, is a calm and steady thing, burning patiently through its long middle age, its surface a smooth glowing sphere, its life unhurried. R136a1 is nothing like that. It belongs to a rare and ferocious class of stars that astronomers call Wolf-Rayet stars, and the name marks them as among the most extreme and violent objects in the entire stellar zoo. A Wolf-Rayet star is a star living at the very limit of its own intensity, burning so fiercely, pouring out so much energy, that it has begun to tear itself apart from the inside out. Let me explain what that means, in plain language, because it is one of the strangest and most striking facts about this star. Most stars, including our sun, keep their outer layers wrapped around them like a blanket, a calm atmosphere of cooler gas surrounding the furnace within. But a star as massive and as luminous as R136a1 produces so much light, such a torrent of raw radiation pouring outward from its core, that the light itself begins to push the star's own outer layers away. The pressure of the light, the simple physical force of all that brightness streaming outward, is so immense that it strips the star's outer atmosphere off and blows it into space. R136a1 has, in a sense, torn away its own outer skin. It has shed the calm blanket that gentler stars keep wrapped around themselves, and what we see now is something closer to the naked, raging interior, the deeper, hotter, more violent layers laid bare. This is what a Wolf-Rayet star is. A star burning so hard it has stripped itself down to its own ferocious core and is shining at us with nothing held back. So that is the character of the thing. Not a calm fire, but a naked one. Not a steady glow, but a roar. Now, let us ask the question we have carried across the entire journey. The question that this whole story has been building toward. How heavy is it? How much matter is gathered into this single fire? Because weight, as we learned long ago with the beach ball and the cannonball, is the true crown, and this star wears it. I want to answer this honestly, because the honest answer is more interesting than a simple one, and because it shows you something beautiful about how we come to know anything at all about the universe. When astronomers first managed to study R136a1, when they first pulled it free from the blur and tried to weigh it, the numbers they arrived at were almost beyond belief. The earliest careful estimates suggested that this star might contain more than 300 times the mass of our Sunday. Sit with that for a moment, against everything we have learned. We honored our sun as the great fire that could swallow 1,000,000 Earths and contains more than 99% of all the matter in our solar system. And here was a single star that might hold more than 300 times the matter of our entire sun, packed into one body. If that figure were right, it would push against the very ceiling of what anyone believed a star could possibly be. It would be a record holder so extreme that it forced astronomers to reconsider the upper limits of stellar mass itself. But here is where the story turns, and where I want you to feel something other than disappointment. Because as our instruments grew sharper, as we learned to separate this star more cleanly from its blazing neighbors in the crowded heart of R136, the picture changed. Remember the problem we wrestled with in the last part, the way the densely packed stars of the cluster smear their light together when seen from 160,000 light-years away. The earliest measurements were made before we could fully separate R136a1 from the stars crowded close around it. And when some of that light was actually coming from nearby companions, the star looked brighter than it truly was, and a star that looks brighter is judged to be heavier. The very crowding that hid the star for so long had also, in a sense, inflated our estimate of its mass. So astronomers built sharper eyes still, instruments capable of teasing this one star apart from its neighbors more cleanly than ever before. And they looked again, and when they did, the numbers came down. The most careful recent measurements suggest that R136a1 is not above 300 solar masses after all, but somewhere in the range of roughly 170 to 230 times the mass of our Sunday, lower than the early estimates, less extreme than the first astonishing figures. Now, I could tell you this and let it land as a letdown, as though the star had shrunk before our eyes, as though we had been promised a giant and handed something smaller. But that would be exactly the wrong way to feel about it, and I want to take a moment to set it right, because this is one of the most quietly beautiful things about the whole endeavor of understanding the cosmos. The star did not shrink. The star has not changed at all. It is exactly as heavy now as it was 1,000 years ago, exactly as heavy as it will be when we are all long gone. What changed was the clarity of our seeing. We looked once through imperfect eyes and got one answer. We built better eyes and looked again and got a truer one. The revision downward is not a failure, it is a triumph. It is the sound of science doing precisely what it is supposed to do, sharpening its picture of the world over time, correcting itself honestly when better evidence arrives, refusing to cling to a thrilling number simply because it was thrilling. The willingness to say, we thought it was this much, and now, having seen more clearly, we believe it is this much instead, is not a weakness in the enterprise. It is the very heart of its strength. Every honest revision is the universe coming a little more clearly into focus. And here is the part that matters most. Even at the revised figure, even at the lower end of the new estimates, R136a1 remains the heaviest single star we have ever confidently identified anywhere in the cosmos. Lower than 300 suns, yes, but still more than 170 times the mass of our sun, perhaps as much as 230, still wearing the crown. Still the cannonball among cannonballs. The picture sharpened, the number came down, and the star is still the most massive known fire in all the heavens. We did not lose the giant. We simply learned to see it as it truly is, which is a far better thing than seeing it as we first imagined it to be. Let me try to make that mass real to you, because 170 or 200 suns is just a number until you feel it. Remember everything we said about our own star. The The Sun contains more than 99% of all the matter in our solar system, all the planets and moons and asteroids and comets reduced to a rounding error beside it. Now, take that Sun, that overwhelming concentration of matter, and gather up not one of them, not 10 of them, but somewhere around 200 of them, and pour all of that matter into a single star. 200 suns worth of substance, 200 times that vast hoard that dwarfs everything else in our solar system, all of it concentrated into one burning body. That is what R136a1 is. It is as if you took 200 complete solar systems, threw away all the planets as the insignificant scraps they are, and merged every one of those 200 suns into a single fire. That is the weight this star carries. That is the crown of mass. And mass, as we learned, is fate. A star this heavy cannot be calm. The sheer, crushing inward pull of 200 suns worth of gravity must be fought every single second by an outward push of equal ferocity. And that push comes from the star burning its fuel at a rate that beggars the imagination. So let us turn from how heavy it is to how brightly it burns, because the brightness is, if anything, even harder to hold in the mind than the weight. Our Sun is bright. It lights an entire solar system. It is so bright that you cannot look at it directly, so bright that its light crossing 93 million miles of space still arrives strong enough to warm your skin and damage your eyes. Hold that brightness as your standard. Now understand that R136a1 does not shine a little brighter than the Sun, or twice as bright, or 10 times. It shines several million times more brightly than our Sunday. Several million. Try to hold that. If you could somehow place R136a1 where our Sun sits, 93 million miles away, it would not warm the Earth. It would scorch it to a cinder in moments. The oceans would boil away, the very rocks would begin to melt, and the world would be sterilized by the raw flood of its light long before anyone could even comprehend what had happened. A star that pours out in a single second more light than our Sun produces in a span of weeks. That is the furnace at the heart of R136, and it is not only bright, it is savagely hot. The surface of our Sun glows at a temperature of roughly 5,500 degrees, hot beyond any earthly fire, hot enough to vaporize anything we could build. The surface of R136a1 is many times hotter than that, blazing at a temperature so extreme that it shines not with the warm yellow-white of our Sun, but with a fierce blue-white, the color of the very hottest fires the universe makes. This is why it is so luminous. A hotter surface pours out vastly more energy from every patch of itself, and R136a1 is both enormous in the energy it produces and ferociously hot across its entire face. It is a blue-white inferno, burning at temperatures our gentle Sun will never come close to in its entire long life. Now picture all of that brightness, all of that heat, pouring outward from the star in every direction at once. And remember what we said about Wolf-Rayet stars, that the pressure of their own light is so great it strips their outer layers away. Here, standing before R136a1, you can finally see that happening. The torrent of radiation streaming off this star is so powerful that it drives a constant, relentless wind of matter off the star's surface and out into space. Not a gentle breeze. A gale of stellar material, gas blown off the star at speeds of thousands of miles every second, streaming outward into the dark in a ceaseless flood. Our own Sun has a stellar wind too, a faint whisper of particles drifting off into the solar system. But the wind of R136a1 is something else entirely. This star is shedding matter so fast, blowing so much of itself away into space, that over the brief span of its life, it will lose a substantial fraction of its entire mass to the wind alone. It is, quite literally, burning so hard that it is throwing itself away, scattering its own substance into the surrounding nebula, feeding the very glow we saw from across the galaxy. Stand in that image for a moment. A blue-white fire, 200 suns heavy, millions of times brighter than our own star, so hot its surface roars in a color our sun will never reach, stripped naked of its outer layers, and bleeding a relentless gale of its own matter out into the dark at thousands of miles a second. This is R136a1. This is the thing we crossed a galaxy to meet. This is what was hiding inside that faint, ignorable smudge low in the southern sky. The smudge you might have mistaken for a wisp of cloud. And here is the quiet weight I want to leave you with, here at the summit of our climb. We began this whole journey with the sun, and we let it be the largest thing you knew, one last time, the great fire of all our days. And now you stand before a star, beside which the sun truly is, at last, the candle I promised you it would become, not as a figure of speech, as a plain description. Set our sun beside R136a1, and it is a small, cool, modest little flame, guttering quietly next to a blue-white inferno. The fire you have known your whole life, the one that warms your mornings and keeps the time of your sleeping and waking, is a candle. And here, 160,000 years of darkness away, burns the bonfire that makes it so. We have reached the top of the climb. We have met the heaviest known star in all the heavens, and we have seen it honestly, with its revised weight and its staggering light and its savage heat and its relentless dying wind. But a fire this fierce cannot last. A star that burns this hard, that throws itself away this fast, is living on borrowed time, racing through its fuel at a rate that guarantees a short and violent life. And that raises the question that waits for us next, the question that every great fire eventually must answer. How long can something like this possibly burn? And what happens when it cannot burn any longer? Rest here a moment before the blue-white inferno, with the candle of our sun small in your memory. We turn soon to the matter of its ending, but for now, simply stand in the light of the greatest fire we know, and let yourself feel how far you have come to see it. Now we come to the strange and sorrowful heart of what this star is, and it begins with a question that sounds simple and turns out to be one of the deepest in all of stellar science. Why are there so few of them? We crossed an entire galaxy to find R136a1. We searched the most crowded, most fertile stellar city in the known universe to locate a single star this heavy. Across the whole vast sweep of the cosmos, stars like this are vanishingly rare. So rare that finding even one is an event worth a journey across the dark. And the reason they are rare is bound up, intimately and inseparably, with the reason they are doomed. Rarity and doom, for a star like this, are the same fact seen from two sides. To understand the one is to understand the other. So let us go gently into the physics of it, translating every step, because the truth here is both simple and heartbreaking. Start with something you already understand in your body. A star is, at its heart, a war. A long, balanced, patient war between two opposing forces, and as long as the war stays balanced, the star lives. On one side is gravity, the relentless inward pull of all that matter trying to collapse toward the center. Remember that a star is an enormous quantity of gas, and all of it has weight, and all of that weight is pulling inward, trying to crush the star down into a smaller and smaller ball. If gravity were the only force at work, a star would simply collapse, falling inward on itself in an instant. Something must push back. Something must hold the star up against the crushing weight of its own substance. And that something is the fire. The fusion burning in the star's core, the same merging of atoms we marveled at when we sat with the sun, produces a tremendous outward flood of energy and pressure, a force pushing outward from the center, holding the star open against the inward crush of gravity. This is the balance. This is the war. Gravity pulling in, the fire pushing out. The two of them locked together in a standoff that can last for billions of years. A star is alive precisely as long as this balance holds. It is, in the most literal sense, holding itself up by burning. Now here is the brutal trade, the bargain at the center of everything, and it is a bargain no star can refuse. The more massive a star is, the more matter it contains. The stronger its gravity, the harder it is pulling itself inward. A star with 200 times the mass of the Sun has 200 suns worth of weight, all pulling toward the center, a crushing inward force almost beyond comprehension. And to hold itself up against that monstrous gravity, the star has no choice. It must burn correspondingly harder. It must push outward with a force great enough to match the inward crush, and the only way to generate that much outward push is to burn its fuel at a furious, blazing, almost unthinkable rate. The heavier the star, the more desperately it must burn simply to keep from collapsing. There is no gentle option for a massive star. It cannot choose to take it slow. Its own enormous weight forces it to burn at a ferocious pace, just to survive from one moment to the next. And here is the cruel consequence. Burning that hard means burning through the fuel that fast. Think of two fires. One is a single candle, burning low and steady, a small flame sipping at its wax, lasting through a long, quiet evening. The other is a great bonfire, roaring, throwing flames into the sky, consuming whole logs in minutes, blazing with a light and heat the candle could never match. Which one lasts longer, you already know. The candle, burning gently, can flicker on for hours. The bonfire, for all its glory, for all its overwhelming brightness, devours its fuel so fast that it burns itself out while the candle is still patiently glowing. The brighter the fire, the shorter its life. This is not a flaw in the bonfire. It is the very nature of burning brightly. To blaze is to be brief, and so it is with stars, but on a scale that staggers the imagination. Our sun is the candle. It is a modest star with modest gravity, and so it needs only to burn gently, sipping at its fuel, holding itself up against its own moderate weight with a calm and patient fire. And because it burns so gently, its fuel lasts an almost unimaginable length of time. Our sun has enough fuel to burn steadily for about 10 billion years. 10 billion. The sun is not even halfway through that span now, which means it has been burning for nearly 5 billion years already and has roughly 5 billion more ahead of it. When you sat with the sun at the start of our journey and felt its patience, its faithfulness, its refusal to hurry, this is what you were feeling. The leisurely, generous, long-burning life of a gentle star, a fire that can keep a world warm for 10 billion years. Now hold that beside R136a1 and feel the difference land. R136a1 is the bonfire. It carries the crushing weight of perhaps 200 suns, and so it is forced to burn with a ferocity beyond anything our sun will ever know, pouring out millions of times more light, just to hold itself up against that monstrous gravity. And burning that hard, it devours its fuel at a rate that guarantees a short and violent life. A star like R136a1 does not get 10 billion years. It does not get 10 million. It gets only a few million years from birth to death. A few million years. Sit with how brief that is against the sun's vast span. If you imagine the sun's 10 billion year life compressed into a single full day, then the entire life of R136a1, from its fiery birth to its violent end, would flash past in just a few seconds. A few seconds against a whole day. The most massive stars are the brightest things the universe makes, and they are also among the shortest lived, blazing into existence and burning themselves out in what is, on the cosmic scale, hardly more than an instant. They are not built to endure. They are built to blaze, and then to be gone. There is something almost unbearably poignant in that, and I want you to feel it rather than rush past it. The grandest, heaviest, most luminous stars, the ones that pour out more light in a heartbeat than our sun produces in weeks, the ones whose single brilliance lights up entire nebulae across thousands of light years, are precisely the ones that cannot last. Their glory is the very thing that dooms them. They shine so brightly because they burn so hard, and they burn so hard because they weigh so much, and burning that hard means they cannot endure. Magnificence and brevity, for these stars, are the same thing. R136a1 is so spectacular precisely because it is racing toward its own end. The bonfire is more breathtaking than the candle, and the bonfire dies while the candle still burns. Now let us go one step deeper, to the question of why there is a ceiling at all, why the universe seems unwilling to make stars much heavier even than this. Because R136a1 is not just rare, it sits very close to a genuine limit, a wall beyond which stars seem unable to exist. And the reason for that wall is one of the most elegant ideas in all of stellar physics, and you already have everything you need to understand it. Remember the war, gravity pulling in, the fire pushing out. We said that a star holds itself up by burning, that the outward pressure of all that light balances the inward crush of gravity. But now think about what happens as you try to build heavier and heavier stars. The heavier the star, the harder it must burn, and the harder it burns, the more light it pours out, and the more powerful the outward push of that light becomes. And here is the crucial turn. At some point, as the star grows more and more massive and more luminous, the outward pressure of its own light grows so overwhelming that it begins to win the war in the wrong direction. The radiation streaming out of the star becomes so forceful that it starts to blow the star's own outer material away, to tear at the very gas that is trying to gather and hold together. We saw this already in the relentless wind streaming off R136a1, shedding its substance into space. That wind is the sign of a star burning so close to the edge that its own light is stripping it apart. So imagine trying to build a star even heavier than R136a1. As you pile on more matter, the star must burn even harder to support the added weight, and burning harder means it shines even more fiercely, and shining more fiercely means the outward pressure of its light grows even stronger, until that light pressure becomes so violent that it simply blows away any additional matter you try to add. The star, in effect, refuses to grow. Its own brilliance becomes a barrier, a furious outward gale that flings away material faster than it can be gathered. There is a point past which gravity, trying to add more mass, loses to the radiation trying to push that mass back out into space. And that point is the ceiling. That is the wall. It is why stars seem unable to exist much heavier than the giants we find in places like R136. The universe is not forbidden from gathering more matter into one place. It is that a star burning hard enough to support that much matter would shine so brightly it would tear itself apart before it could finish forming. The light wins. The star cannot grow past the point where its own glory undoes it. This is part of why R136a1 is so precious to us and so rare. It lives pressed right up against that ceiling, near the very edge of what a star is permitted to be. It is one of the heaviest objects that can hold together as a single burning star at all, balanced on the knife edge between the gravity gathering it in and the radiation trying to blow it apart. Stars this close to the limit are not common products of the universe. They form only under special conditions, only in the densest and most fertile nurseries, only rarely and only barely. The conditions that can assemble so much matter into a single star without the star's own ferocity scattering it are uncommon and difficult. The universe makes these giants only with effort and only seldom. And then, having made them so rarely, the universe takes them back almost at once. This is the final piece of why we see so few of them, and it is the place where rarity and doom fold completely into one. These stars are born rarely, and they die almost immediately. A few million years, against a universe that is well over 13 billion years old. Do the arithmetic of it in your heart. The cosmos has been making stars for more than 13 billion years. A star like R136a1 lasts only a few million of those years before burning out. Which means that almost every star, this massive that has ever formed in the entire long history of the universe, across all that time, is already gone. Billions of years of cosmic history, and a star this heavy survives for only the briefest sliver of it before it dies. The ones we see now, the precious few like R136a1, are the rare living examples that happen to exist in our own brief moment of looking. Almost all the others, the countless giants that blazed across the eons before us, have long since burned out and met their ends. We are seeing one of the last few candles still lit at the end of an enormously long night, and even calling it a candle is wrong because it is a bonfire, and the bonfire is already nearly spent. Let that settle into the quiet. R136a1 is rare because it is hard to make and quick to die. It is rare in space, found only in the most extraordinary corners of the cosmos. And it is rare in time, existing only for a flicker against the vast age of the universe. To have found it at all, to be alive in the brief window during which it still burns, to have crossed the dark and learned to see it clearly before it is gone, is a kind of fortune. We are watching something that the universe makes seldom and keeps only briefly. We caught it mid-blaze, in the short, fierce instant of its life, and soon, on the cosmic clock, that instant will be over. Because a star burning this hard, racing through its fuel at this furious pace, is running down even now. Every second we have spent admiring it, it has been consuming itself, throwing its substance into space, drawing closer to the moment when the fuel finally fails and the long balanced war between gravity and fire comes to its end. And when the fire can no longer push back, when the fuel is spent and the outward pressure collapses, gravity, which has been waiting patiently the whole time, which never tires and never relents, will finally win. The standoff will break. And what happens in that moment, when a star of 200 suns can no longer hold itself up, is one of the most dramatic and surprising events in all of nature. You might think you know what comes next. A star this large, this violent, this spectacular, surely it must end in the grandest explosion the universe can produce, the brightest death imaginable, a blast of light to match the glory of its life. It is the natural thing to expect. It is what the whole story seems to be building toward. But the death of the very heaviest stars is stranger than that. Stranger and quieter, and in some ways far more unsettling than any explosion. What happens when a giant like R136a1 finally falls is not quite what anyone would guess. And that is where we turn next, into the strange and humbling matter of how something this immense actually dies. Rest here a moment first, in the light of a fire that is already, even as it blazes, beginning to run down toward its end. So let us go to the ending. Let us follow this great fire all the way to the moment when it can burn no longer, and let us see what becomes of a star so heavy that it sits at the very edge of what the universe permits. But before we do, I want to honor the expectation you almost certainly carry, because it is a reasonable expectation and a beautiful one, and most people share it. You probably expect an explosion, and not just any explosion. You expect that a star, this immense, this violent, this spectacularly luminous, must end in the grandest possible blast, the brightest death the cosmos can stage. It makes a kind of poetic sense. A star that lived so fiercely, that poured out millions of times the light of our sun, that lit an entire nebula across thousands of light years. Surely such a star must die in a way that matches its life. Surely it must detonate in a supernova so brilliant it briefly outshines whole galaxies, a final flash of glory befitting the heaviest fire in all the heavens. The life was magnificent, so the death must be magnificent too. That is the story we expect. That is the ending the whole journey seems to promise. And I want to tell you that this instinct is not foolish. It is grounded in something true. Massive stars do, very often, end in supernovae, in titanic explosions that are among the most violent events the universe produces. When a heavy star exhausts its fuel and the long war between gravity and fire finally tips, the collapse of the core can rebound into a catastrophic explosion, blasting the star's outer layers into space in a flash of light visible across enormous distances. These supernovae are real, and they are spectacular, and they seed the cosmos with the elements that fire forged in the star's heart, the very atoms that go on to make new worlds, and, eventually, living things. So your instinct that a massive star dies in a great explosion is, for a great many stars, exactly right. It is one of the central truths of how the universe works. But, and here is where the story turns, where the expectation we have carried all this way begins to bend into something stranger. For the very heaviest stars, the ones at the absolute extreme of mass, the ones like R136a1 pressed right against the ceiling of what a star can be, the ending may not be an explosion at all. It may be something far quieter, far stranger, and in some ways far more unsettling than any blast of light. Because when a star is this massive, the rules begin to change. Let me take you into the final moments, gently, step by step. Remember the war we described, gravity pulling in, the fire pushing out, the two locked in balance for the whole life of the star. For a few million years, R136a1 has held that balance, burning ferociously to support its own crushing weight. But the fuel is finite. No matter how vast the star, the fuel will run out, and for a star burning this hard, it runs out fast. And in the final stages of its life, the star works its way through heavier and heavier fuels, burning through one kind of fuel and then igniting the ashes as a new fuel, each stage briefer than the last, the whole process accelerating toward an end, until at last it reaches a fuel it cannot burn. It builds up a core of material that produces no more outward push, no more energy to hold back the gravity. And in that instant, the fire that has held the star up for its entire life simply fails. Now picture what happens. For millions of years, gravity has been pushing inward, relentless, patient, never tiring, held off only by the outward pressure of the burning core. And now, suddenly, the outward pressure is gone. The thing that held the star open vanishes in moments. And gravity, which never stopped pulling, which has been waiting this whole time, finally wins, completely and at once. The core, no longer supported, collapses. It falls inward on itself with unimaginable speed and force, the entire central mass of the star caving toward the center in a fraction of a second. For a star of more ordinary mass, this collapse triggers the great rebound, the supernova, the explosion that blasts the outer layers away. The infalling material crashes onto the collapsing core and bounces, and that bounce drives the catastrophic blast. But for a star as massive as R136a1, the gravity is so overwhelming, the inward crush so absolute, that there may be nothing strong enough to stop it. The collapse does not bounce. It does not rebound into an explosion. It just keeps falling. The core caves inward so violently, with so much mass pressing down, that it passes a point of no return, folding in on itself so completely that not even light can escape from what it becomes. The star does not blow itself apart in a final flash of glory. It collapses almost directly inward, folding down past the threshold beyond which nothing returns. And in that moment, it becomes a black hole. Sit with how strange that is, how it overturns everything the story seemed to promise. We expected the brightest death the universe could offer, and instead, for the very heaviest stars, the ending may be a kind of vanishing. Not a blast of light flung across the cosmos, but an inward fall so complete that the star simply folds out of the visible universe altogether. Where there was a blazing fire, a torrent of light millions of times brighter than our sun, there is now a region of space so warped by gravity that no light can leave it at all. The brightest thing becomes, in an instant, the darkest thing there is. The most luminous fire in all the heavens collapses into perfect darkness. There may be little or no explosion to mark it, little or no final flash. Just a giant that was here and then is not, having fallen inward through its own gravity into a black hole, swallowing even its own light as it goes. There is something almost unbearably moving in that image. A star that lived as the most spectacular fire we know, that we crossed a galaxy and learned to see across 160,000 light years of darkness, ending not with a shout, but with a kind of silence. Not scattering itself across space in a blaze of glory, but folding quietly inward, drawing even its own light down into the dark with it. The grander the fire, the quieter, in the end, the going. The very weight that made it so magnificent is the weight that, at the last, pulls it down past the edge of the visible world without a sound. But I have to be honest with you here, the way we have tried to be honest about everything on this journey, because the truth of these endings carries real uncertainty, and that uncertainty is part of the wonder rather than a flaw in it. The deaths of the most massive stars are among the hardest things in all of astronomy to pin down with confidence. These stars are rare, their deaths are rarer still, and we have witnessed only a handful of such events across all our watching of the sky. So when we ask exactly how a specific star like R136a1 will die, we are reaching toward the edge of what we currently know, and honest scientists hold several possibilities open at once. The direct collapse into a black hole, the quiet inward folding I just described, is one real possibility, and for a star this massive, it is a serious one. But it is not the only ending the universe might have in store for a giant like this. There is another possibility, stranger still, and in its own way, even more extreme. For stars in certain ranges of enormous mass, the final stages can trigger a runaway process so violent that it does not merely explode the star, it obliterates it entirely. In these extraordinary detonations, the conditions in the dying core become so extreme that the star tears itself completely apart in a blast even more powerful than an ordinary supernova, a detonation so total that it leaves nothing behind at all. No black hole, no dense remnant, nothing. The entire star, all those hundreds of suns worth of matter, scattered utterly into space, the giant erased from existence in a single cataclysmic flash, leaving only an expanding cloud and an empty place where a star once burned. to end not by folding into darkness, but by being scattered so completely that not even a corpse remains. So which will it be for R136a1? The quiet inward collapse into a black hole, folding down into silent darkness, or the total annihilation, the detonation that leaves nothing behind? The honest answer is that we do not know with certainty, and that the answer depends on details of the star's mass and its inner workings, and the precise path it takes through its final stages, details that lie right at the frontier of our understanding. The most massive stars sit in a regime where the rules grow subtle and the outcomes branch, where small differences in the dying star can send it toward wildly different ends. And the mass of R136a1 itself, as we learned, is something we are still refining, still bringing into sharper focus. The star sits in exactly the range where its fate is genuinely uncertain, where it could fold quietly into a black hole or could erase itself in a final blast, and where careful, honest people still weigh the possibilities. I find that uncertainty beautiful rather than frustrating, and I hope by now you do too. We have learned on this journey to treasure the honest revision, the willingness to say we do not yet fully know. The fate of R136a1 is not a settled fact waiting in a book. It is a living question, one of the genuine mysteries still standing at the edge of what we understand, a place where the universe has not yet finished teaching us. The star will answer the question itself, in its own time, in a few million years, long after every one of us is gone. And perhaps by then those who come after us will have learned to see clearly enough to know in advance which ending the giant has chosen. For now, we stand before it, knowing only this, that it will die, that when it dies, it will do so in one of the most extreme ways the universe permits, and that the heaviest fire we know may end not in the blaze of glory we expected, but in a silence that folds it out of the visible world entirely, or in an annihilation so complete that nothing of it remains. Either way, it will be gone. This is the part I want you to feel most of all, here, near the end of the story of its death. Whatever the precise manner of its ending, R136a1 will not endure. The most massive star in all the heavens, the great blue-white inferno we crossed a galaxy to meet, is living on borrowed time, and its time is short. In a few million years, a mere flicker against the age of the universe, this fire will go out. The light that now blazes across the Tarantula Nebula will fail. The wind streaming off its surface will cease. And in the place where the heaviest known star once burned, there will be either a region of perfect darkness, a black hole holding the ghost of the star's gravity, or an expanding cloud and an empty silence where a giant used to be. Let the cadence slow now. Let us not rush away from this. There is a particular feeling that comes from contemplating the death of something so vast and so distant and so far beyond us, and I want you to let yourself feel it. It is not grief, exactly. You cannot grieve a star the way you grieve a person, but it is something adjacent to grief, a kind of solemn tenderness, a reverence for the fact that even the grandest things end. The heaviest fire the universe knows how to make is mortal. It was born, it blazed, and it will die, and its death will be as extreme and as humbling as its life. There is a strange comfort buried in that, if you sit with it long enough. Everything that blazes will one day go dark, even the giants, even the brightest of all. And there is no shame in that, no failure. To have burned at all, to have blazed across the dark for even a few million years, to have lit a nebula and been seen across a galaxy and been understood, at last, by small, curious creatures 160,000 light years away, is its own kind of glory, whether the ending is a blast or a silence. So let us stand quietly for a moment longer in the light of R136a1, knowing now that the light is temporary, that the fire is already running down, that one day, on the long clock of the cosmos, this place will be dark. The greatest star we know is dying slowly, even as it blazes. And there is something in that knowledge that softens everything, that turns the fierce blue-white inferno into something almost gentle, almost intimate, a vast and temporary thing burning bravely in the dark, on its way, like all things, toward an ending. And now it is time to come home, time to leave the dying giant where it burns, 160,000 years away, and make the long journey back across the dark, back to the small warm world we left, back to the room where you are resting, back to your own quiet breath in the dark. Let your eyes grow heavy if they wish. The hardest climbing is behind us. What remains is only the gentle descent, the slow return, the soft landing back into your own body and your own night. Come back with me now, slowly, and let us see what all of this means, in the end, for you. And now we begin the long way home, slowly. There is no hurry in this last part of the journey, and there never was any hurry, not really. We came all this way to stand before the heaviest fire in the heavens, and now, gently, we turn around, and we begin to drift back toward the small, warm world we left behind. Let the turning be soft. Let it feel like the moment at the end of a long day, when you finally lie down and let your weight settle into the bed beneath you. Take one last look at R136a1 before we go. There it blazes. The great blue-white inferno, 200 suns heavy, millions of times brighter than the candle of our own star, shedding its substance into the dark, burning ferociously toward an ending it cannot escape. We know its secret now. We know that for all its overwhelming glory it is brief. We know that it is already running down, that the fire we are watching is a temporary thing, that in a few million years this place will be dark or empty or folded into silence. We came to find the greatest star, and we found it, and we found, woven into its greatness, its mortality. Let it burn there behind us as we turn away. We will not see its ending. No one alive will. But we have seen it live, and that is enough. Now drift outward. Let the blazing cluster of R136 begin to recede, the crowded city of giants pulling back into a single brilliant knot of light. Watch the great streamers of the Tarantula Nebula widen around you again, the glowing sheets and the towering pillars of dust, the fevered nursery where stars are born in their thousands. We pass through here on the way in, full of anticipation, climbing toward the giant at the center. Now we pass back through it on the way out, and it looks different somehow, softer, knowing what we know. All this creation, all these newborn fires lighting up the gas. Somewhere among them, perhaps, are other giants being born even now. Future R136, a 1S gathering themselves out of the collapsing clouds, destined to blaze briefly and die. The nebula glows on, indifferent to us, beautiful, vast, and we slip out through its glowing edge and back into the dark. And now, the great crossing, 160,000 light years of emptiness between that galaxy and our own. Let it pass slowly. Watch the large Magellanic Cloud shrink behind you, the whole ragged, beautiful galaxy drawing back into the distance, becoming again what it was when we started, a faint, pale smudge low against the dark. Remember how we began, with that smudge in the southern sky, the one you might mistake for a wisp of cloud. We know now what hides inside it. We know about the fevered nebula and the city of giants and the heaviest fire of all. But to anyone standing on the earth looking up, it is still just a faint, soft patch of light, quiet and unassuming, keeping its enormous secret. There is something lovely in that. The grandest things do not always announce themselves. Sometimes the most extraordinary fire in the heavens hides inside the dimmest smudge in the sky, waiting patiently to be understood. Cross the dark. Let the large Magellanic Cloud fall away entirely. Ahead of you now, growing slowly, is the great spiral wheel of our own galaxy, the Milky Way. Hundreds of billions of stars wound into glowing arms. We left from here. This is home, or the neighborhood of home. Drift in toward it, into the familiar spiral, in toward one quiet arm out near the edge, in toward one small ordinary star drifting in spacious solitude with its little family of worlds circling around it. Our Sunday. The candle, the fire of all our days. And here, on the way back, with everything we have seen still glowing in our minds, I want to stop for a moment and look at our sun again, because it is not the same sun we left. Or rather, it is exactly the same sun, and we are not the same. We began this journey by sitting with the sun and letting it be the largest thing we knew, the great fire that could swallow 1,000,000 Earths. And then we learned how small it truly is, how it is closer to a candle than a bonfire, how the heaviest stars make it look like the faintest ember. We let the sun be humbled before the giant. We let it shrink in our estimation against the blue-white inferno of R136a1. But now, coming home, I want to give the sun back something that the giant cannot have. Because there is a question hiding underneath this whole journey, and now, at the end, it is time to ask it gently. We have spent all this time in awe of the heaviest star, the most massive, the most luminous, the most extreme. We treated mass as the crown, the true measure of greatness. And it is a crown, a real one. But sit with this. R136a1, for all its immensity, gets only a few million years. It blazes and it dies in what is, on the cosmic clock, hardly more than an instant. And our sun, the modest little candle, the unremarkable middleweight star, gets 10 billion years. 10 billion. The giant burns brighter in a single second than the sun does in weeks, and the sun outlives it thousands of times over. So which is the greater gift? The blazing brevity of the giant, or the patient endurance of the candle? I do not think there is a single answer, and I do not want to hand you one, because the beauty of the question is that it does not resolve. But consider this. Here, in the quiet, everything you are, everything you have ever known, every person you have loved, and every morning you have woken to, all of it exists because our star is patient, because it burns gently, because it does not blaze itself out in a few million years, but holds steady across billions, long enough for worlds to cool and oceans to gather and life to stir and slowly, slowly become something that could look up and wonder. A star like R136a1 could never give that gift. It dies far too quickly for anything to take root around it, far too violently, gone before the first stirrings of anything could even begin. The giant is magnificent, and the giant is sterile. Its glory is real, and its glory is brief, and nothing can live in the shadow of a fire that burns out so fast. But the candle, the patient, modest, ordinary candle, the star burns long enough for you to exist. Immensity and permanence, it turns out, are not the same thing. The heaviest fire is not the lasting one. The most spectacular star is not the one that makes a home. And the quiet, faithful, unremarkable sun that you have looked past your whole life, the one that seemed so small the moment we measured it against the giant, may in the end be the greater gift, precisely because it is patient, precisely because it stays. The giant blazes and is gone. The candle keeps the world warm long enough for someone to be alive inside it, wondering about giants. So let the sun be small, yes, but let it also be enough. Let it be exactly the kind of star that a life like yours could grow beneath. There is a tenderness in that, a quiet gratitude available to you now that was not available before, when the sun was simply the bright thing you turned your face away from. The next time you feel its warmth on your skin, you will know that you are being warmed by a modest star, a candle in the wider dark, and you will know that its modesty is the very reason you are here to feel it. And now, gently, come the rest of the way home, past the sun, in toward the small blue world circling it, down through the thin, bright skin of atmosphere, down through the clouds, down toward the darkened half of the turning earth, down toward the quiet place where you are resting, down into your room, down into your own body, lying here in the dark, at whatever hour it has become. Feel yourself arrive back. Feel the surface beneath you, holding your weight. Feel the blanket over you, its gentle pressure, the small warmth it traps against your skin. You traveled so far tonight, across 160,000 light years and back, and you never left this room. The whole vast journey happened in the warm dark behind your eyes, and now it folds quietly closed. And here you are, exactly where you began, in your own bed, in your own breath, in your own small warm life. Notice your breathing. You do not have to change it. Just notice it. The slow rise, the slow fall, air moving in and air moving out. The same patient rhythm that has carried you through every moment of your life, faithful as a steady star. There is no giant here, no blazing inferno, no collapse, no annihilation, no fire racing toward its end, only your breath, soft in the dark, and the weight of the blanket, and the quiet fact of being alive. Think, for one last gentle moment, of what you now carry. 160,000 light years away, a star heavier than 200 suns is burning toward its death. It does not know you exist. It will be gone long before anyone you will ever meet is born. And yet you, here, small and warm and breathing in the dark, you know about it. You crossed the distance in your mind and stood before it and understood it. That is a strange and wonderful thing. The universe made a fire so vast, it sits at the edge of the possible, and it also made you, soft and brief and curious, able to know that the fire exists. The giant cannot do what you are doing right now. It cannot wander, it cannot rest, it cannot lie in the dark and feel the weight of a blanket and be glad to be alive. Only the small warm things can do that. Only you. So let the giant burn, far away, in the dark. Let it keep its crown of weight. You have something it does not have. You have this moment, this breath, this quiet, this life beneath a patient star. Let your body grow heavy now. Let it sink a little further into the bed. There is nothing left to climb. The journey is done. You have seen the heaviest fire in the heavens, and you have come safely home, and now there is only rest. Let the giant fade. Let the nebula fade. Let the long dark between galaxies fade, and the spiral wheel of stars, and the small blue world turning in the night. Let all of it grow dim and soft at the edges. You can keep it. It will still be there tomorrow, the whole vast sky and everything in it. You do not have to hold it now. Just breathe. The sun will rise again tomorrow, faithful, patient, small, and exactly enough. It will warm your window the way it has warmed every window of your life. And now you will know what it is, this modest little candle that lets you exist. But that is tomorrow. For now, it is night. For now, you are here. Feel the weight of the blanket. Feel the breath move through you, slow and soft. Somewhere far away, a giant burns. And here, In the warm dark, you rest beneath a gentle star. Let your eyes close. Let the sky hold itself tonight. You are home. You are warm. You are here. Rest now. Sleep.